We can start with the presentation of Professor Adeyemi. We will start with the first one, the presentation of Dr. Jimar Ben Sidhom. He will present his work dealing with assessment of date palm biomass waste valorization using PGCMS with focus on renewable biofuels and biochemical production.
But I am Dr. Kudrat Adeyemi. Yes, I'm presenting to you investigating geostationary temperature of the nocturnal transition within the surface boundary layer using Fourier spectral technique in Port Harcourt City, Nigeria. Next slide, please. Go to the next slide. Let's look at the outline. I have the introduction, the objective, methodology, results, discussion, and the conclusion. Next slide. Let's start with the introduction of the terms. We want to look at some of these terms that I have used in, the study work in order for me to get the result we got at the end of this study. We want to look at what geostationary is and why do we use geostationary. We want to know why are we looking at the surface boundary layer among other layers that we have in the atmosphere. Why is it the SBL that is our point of interest? And we also want to understand the word nocturnal transition. Why is the focus of this research work on that particular layer that is at the close to the surface of the Earth? The word geostationary came as a result of the revolution of the Earth. As we all know that the Earth revolves 24 hours, that's sunset and sunrise and sunset. So what we did here was to acquire our data using that idea, daily acquisition data, so that we can have all the necessary information that we need to so that we can have a good result in our research work. So we are able to make a daily acquisition data there. Then we stay at the SBL, that is the surface boundary layer, because it is the habitable layer where all human activities takes place. Because we are looking at the problems or the challenges that climate change is giving to us and how can we combat it? Which area are we contributing to it? And how can we mitigate this negative contribution of ours? So that is why we try to look at where we live, where we carry out all our activities. And we know that at this layer, many of these meteorological phenomena occurs here. Then another word that we are going to take into consideration is the word nocturnal transition. Why is it so? Because at this particular layer, it is expected that, at the troposphere, we expect that the temperature there, decreases, falls as we go higher in height. But at this particular layer of this troposphere, we find out that there is an inversion. That is, temperature increases at this particular height. So we are going to see what really happened at this particular layer of the troposphere. The next slide, please. The objective of the work. The next slide. Next slide, please. Hello, next slide. Okay, sorry, objective, back. So let's look, we want to understand the physical processes in Port Harcourt. Studying this particular weather parameter, that is the temperature. As we all know, it's not that other parameters are not of importance. They are all of importance to us as an atmospheric observant. But because of the sensitivity of this particular weather parameter, that is why we need to make use of it for us to be able to understand the physical processes that is happening in Port Harcourt. That is, we want to look at the extension of the rain and the dry season. Here in Nigeria, we basically talk about the rain season and the dry season. But I know in other words, we'll talk about your spring, your winter, your summer, and so on and so forth. But here, we talk about the rain and the dry season. And we want to also know the shortness and the hotness of the dry season. That is the physical processing that is happening in Port Harcourt. And another thing that we want to understand here is the meteorological conditions, which we have been able to see from the results of this research work. That is example of the cloudiness, the front, the precipitation, and so on and so forth. Then also the air quality that we have around in Port Harcourt in order for us to combat the problem of climate change. But before I go on, the one interesting thing about this work was that when this research work was being carried out in Port Harcourt City, that was in the year 2017 and 2018, there was an environmental challenge that was in place in that city, and that is the problem of black soot. So the problem of black soot gave the idea to this particular research work, and we've been able to identify some of these atmospheric problems, climatic problems that comes out from that particular challenge that was happening in the Port Harcourt City. Next slide, please. Methodology. The logger was used to measure the Earth reflected radiation and the Earth emitted thermal radiation in order for us to have a scientific investigation of the atmospheric diurnal cycle. You know, that knowledge must be put in place. So on this note, data were acquired, and this data were averaged hourly. And this was carried out for 2 years. And it was later grouped into 4 quadrants. Why did we have to group it? We want to avoid temperature swing. So that's why we group the data into 4 quadrants. That is all 6 hourly, from 12 a.m. to 6 a.m., 6 a.m. to 12 midday, then from 12 midday to 6 p.m., then 6 p.m. to 12 a.m. So, but our area of interest here is the one of 6 p.m. to 12 a.m. That is the focus of this research for the 3rd quadrant out of the 4 quadrants that we have. A MATLAB 217 was used for digital signal processing. Histogram charts were plotted and interpreted. Next slide, please, for the results. You can see here on the screen, we have year 2017 histogram results for the 3rd quadrant. And here we have a normal distribution curve that is fitted to this temperature histogram chart. Why did we have to do that? Because we want to skew the temperature data for us to be able to acquire the knowledge of the diurnal cycle. And from here, because we have used the normal distribution curve fitted into it, you can see that we have the outliers or the extreme temperatures were also seen outside these curves for the 2 years. You can change it to the next slide. For 2018, you will see it for the 3rd quadrant. For the year 2018, you can see the same thing, that at 25 and 28 degrees, that we have more of this, the temperature occurs more in this particular year. So the discussion on the results, let's go to the next slide. That's the discussion. For the year 2017 chart, you will see that the extreme temperature is at 25.5 degrees Celsius, and this occurs for 80 days in the year. Then for 2018 chart, that's the second one, you can see that we have 2 distinctly extreme temperatures. If you look at it, that's at 24 and at 28. 2 distinctly extreme temperatures. That is the focus of our interest, having seen this. So if you look at that, let us go to one of the characteristics of fronts, which says that when you have temperatures that are distinctly separated within a short, relatively short distance, then there is possibility that those temperatures are fronts. And you know that front is as a result of problem facing air masses. And air masses is very important when we are talking about weather. So that is where the interest of this work lies. So from here, we can likely say that we have 2 fronts that are driving from the chart of 2018. Then this could be due to the anthropogenic activities that was ongoing in Port Harcourt City during the period of this study. Then secondly, we can say that uneven solar heating due to meteorological conditions of this weather may have been the cause. As long as there is a problem in the air is not having, the air is being polluted, then automatically there will be uneven solar heating, which may result into meteorological hazard condition. Then another thing that may have caused this fronts that we have in the chart, histogram chart of 2018 may likely be due to anthropogenic activities, that is as a result of the black soot. And as we all know, that black soot is a good absorber of heat. Is a good absorber. So once we have black soot all over the Earth's surface in a particular environment, then we should be expecting a climate issue, a climate challenge there. So this black soot might have behaved as a black body or a black bed on the Earth's surface by absorbing solar radiation, and this will have increased the thermal mass and also reduced the temperature perturbation at that point of study. Then lastly, my conclusion, the last slide, please. Next. Conclusion. So here, we can say that the effect of the particulates in the atmosphere will definitely alter the Earth's radiation budget. And what do we mean by the Earth's radiation budget? We are talking about the incident short-wave radiation. We are talking about the reflected short-wave radiation, and we're also talking about the emitted long-wave radiation. So this will have been altered as a result of the black body that is all over the surface of Port Harcourt City at the period of study, which may have distorted the thermodynamic state of the atmosphere. Then another thing that I would like to say here in my conclusion is that the direct effect of aerosols is to alter vertical temperature profile, which we all know, that any change in temperature, either increase or decrease, will definitely affect the meteorological condition of a place. And as we know, front is a meteorological condition. Then lastly, accurate dynamic and thermodynamic representation of the SBL, that is the surface boundary layer, contributes to a better understanding and prediction of the local aerosols contributions. So this is a local aerosols contribution to the land, to the city of Port Harcourt here in Nigeria at the period of study. And we have used this study to be able to identify the effect, the negative effect of this black body in that environment. Thank you as you're listening. Thank you for listening.
Thank you very much, Professor Adeyemi, for this nice presentation. Very, very interesting results and findings. Thank you. Our next presentation will be given by Dr. Jimar Ben Sidhom, who will present the assessment of date palm biomass waste valorization using PGCMS with focus on renewable biofuels and biochemical production. So, Jimar, you can share your screen. It's okay now.
Dear professors, colleagues, and esteemed participants, good afternoon. I am, introducing myself. I am Jimar Ben Sidhom.
Excuse-moi, please. يا أنيكو عندك كانت نجم واحدة من الناس سكر. Okay, please. Thank you. Sorry for interrupting.
Is it clear now?
Yes, you can start.
Okay, thank you. Dear professors, colleagues, and esteemed participants, good afternoon. Let's introduce myself first. I am Jimar Ben Sidhom, a postdoctoral researcher affiliated with the team of waste energy valorization at the Research and Technology Center of Energy, Technopark Boursidria in Tunisia. It's an honor to stand before you today virtually to share insights into our research on the assessment of date palm biomass waste valorization using PGCMS with the focus on renewable biofuels and biochemicals production. In the next few minutes, I will guide you through our innovative approach and key findings, exploring the potential applications of PGCMS in transforming date palm biomass waste into sustainable biofuels and biochemical. Without further ado, let's delve into the heart of our research and the promising prospect it holds. The world faces critical energy and environmental challenges due to fossil fuels. The extraction and use of fossil fuels contribute to pollution and climate change. However, lignocellulosic biomass, like date palm seeds, emerges as a promising solution, offering a renewable and cleaner alternative to replace fossil energy source. These seeds are renewable, readily available, and don't compete with the food crops. So an effective method to harness energy from this biomass is through fast pyrolysis using PGCMS. This process yields a type of oil or bio oil, which can be used to produce high-value chemicals and replace petroleum-based fuels. So this study shows a detailed description of the pyrolysis behavior by PGCMS, giving an extensive explanation of the compounds formed and relating it with the composition of the date palm waste. Moving on to materials and methods used in this study. It's an overview of our tools and experimental setup used in this study. The date palm seeds were collected from the Era Gbili from Tunisia, and the used particle size of this biomass was between 0.125 millimeters to 0.25 millimeters. The determination of the proximate analysis and thermal behavior of the date palm seeds sample using a thermogravimetric analyzer, and for the determination of ultimated analysis and high heating value using the elemental analyzer. Concerning the pyrolysis of the date palm seeds, sample was conducted in CDS bioprobe model 5150. The runs were conducted at 3 different temperatures, 450, 500, and 600, for 40 seconds as a whole residence time. The volatiles generated were transferred through a heating line to GCMS for analysis. Accordingly, the gas released from the pyroprobe was collected in a bag and analyzed using a micro GC. Now, let's delve into the results as observed in this table. Our biomass presents low moisture and ash content, high volatility and fixed carbon, high heating value. These findings prove that our date palm seeds biomass is an attractive source for energy production. It could generate useful biofuels. Following that, we have a thermogravimetric analysis which presents the major mass loss in biomass occurs through the decomposition of its primary lignocellulosic components, particularly between 180 and 285 degree. We observe the breakdown of hemicelluloses, moving on to temperatures ranging from 250 to 360 degree. The cellulose decomposition takes place. As we progress to even higher temperatures, from 350 degree up to 600, we witness the gradual decomposition of lignin. Moving now to the part of the PGCMS characterization. In the DPS pyrolysis process, notable compounds are formed, including anhydrosugars. It's up to 23% at 450 degree. The acids up to 20% at 500. The ketones up to 17% at 600 degree. The furans up to 14% at 500 degree, and the phenols up to 4% at 500. These compounds play diverse roles. For example, the aromatic and aliphatic hydrocarbons, along with alcohols, are valued for biofuel production, whereas phenols and furans are considered high added value chemicals. The acids contribute to the corrosiveness of bio-oil and are undesirable. Similarly, ketones and aldehyde linked to bio-oil instability during transport and storage are also undesired. So undesirable compounds further include ethers, esters, and oxygenates, which reduce the bio-oil's heating value. Additionally, polyaromatic hydrocarbons, nitrogen, and sulfur compounds are environmentally detrimental. Moving now, as the major within the family of anhydrosugars, levoglucosan is the compound with the highest concentration. Its maximum content was obtained at 480% of around 18%, and it then decreases to 6% at 600. The levoglucosan has a potential interest for the production of pharmaceutical surfactants and biodegradable polymers. So let's move in now to the characterization of the syngas. At higher temperatures, the dihydrogen, the methane, and monoxide carbon concentrations increase, while the dioxide carbon decreases. The opposite trends for monoxide carbon and dioxide concentration during pyrolysis result from different production mechanism. So the dioxide carbon release is mainly from primary pyrolysis, while secondary pyrolysis is responsible for monoxide carbon and methane release. This clarifies the higher dioxide carbon concentration at 450 and the lower monoxide carbon concentration originated from the secondary reaction at higher temperatures. To sum up now, the PGCMS results show that our date palm seeds pyrolysis leads to a mixture of oxygenated compounds, the anhydrous sugars, acids, ketones, furans, and phenols. Within the family of anhydrous sugars, levoglucosan is the compound with the highest concentration. It's the main cellulose degradation compound. Concerning the influence of temperature on its production, the highest concentration was obtained at 450 degree with a value of around 18% for date palm seed pyrolysis, and significantly decreased at higher temperatures due to its cracking. The fast pyrolysis streams obtained from the date palm seed are interesting for its valorization, with the best option being the extraction of commercial interest compound such as levoglucosan and furans, and catalytic processing, reforming, cracking, hydrocracking of the remaining oxygenate compounds for the production of dihydrogen, hydrocarbon fuels, and chemicals. So the results obtained for the date palm seed sample are encouraging, and therefore the basis for a future development of a fast pyrolysis unit for the treatment of this abundant agriculture waste in Tunisia. Thank you for your attention.
Thank you very much, Jimar, for this nice presentation, for your interesting results and findings. Please let me remind that all questions, or the question and answers session will be done at the end of this session. So please keep connected to the session until the end, and we will have some question to related to your work. So now we can move to the next presentation, A41, with the, Professor Mikhail Goh from Kenya. Hello, Professor. Professor Goh.
Yes.
How are you?
Thank you so much, Chair.
Thank you.
My colleague is putting on the slides, and maybe before I get started, I will introduce that three of us did research on policy on circular economy and waste management in Kenya. In Kenyan policies and the frameworks. And my names are Michael K. Koech from Kenyatta University, School of Agriculture and Environmental Sciences. And
are you a co-author of this? Please, are you a co-author of this work?
Yes, we worked. Yeah, we did work together on this research project on circular economies and policies in Kenya.
Just if you can give me the entire your name that I have to mention this, okay?
Yeah, my name is Michael K. Koech, as indicated in the slide 1, and my colleague Mr. Kaburu Munene.
Okay.
And the third colleague is Mr. Philip Wangia, as indicated on the slide projection.
Okay, you are welcome, and you can start, Professor.
Thank you so much,
Chair.
You.
Thank you very much. Thank
you. Jeremy, now I would like to say that circular economy is growing in Africa, and I'll highlight some of the key issues that are taking place.
Yeah, we were just, our paper focused more on framing, and just to begin, as the Prof was mentioning, is that circular economy is a new area in Africa, but we have seen several efforts by the government and also the private sector, when because the issues of circularity agenda in Africa, they want to align them on green innovation and provision of the provision of jobs, the provision of jobs to the young people. And just to highlight some of the efforts that are ongoing, the major one has been the development of the African Circular Economy Alliance. This is an initiative that began with 3 countries, Rwanda, Nigeria, and South Africa, and they wanted to focus on how they can explore the issue of circular economy so that they can spur their economic growth. The alliance is now growing with the other African countries joining. But also when we look at the issues of circular economy, African countries that have policies, we can see, as highlighted in this map, quite a number of them have policies that relate to extended producer responsibility. This means that people who are bringing products to the market have to find a way of taking care of them, either reducing that, recycling. But we are also seeing the issues of the circularity being mainstream into existing policies. I will focus on some of the small micro-enterprise activities happening in Kenya. We have started to see startup organization coming up with economic ventures on production of organic waste from the municipal waste and some of the waste that is disposed within the cities, as highlighted in the first picture there on your right. And then we have seen some companies come up with storage facilities to help farmers so that they can reduce the post-harvest losses. And these are some of the issues that are now gaining momentum, especially in the hinterlands and the rural areas in Kenya. But we have also seen the establishment of the African largest renewable solar plant in Kenya. So these are some of the practices that we can see the people in the country have begun to embrace issues of circularity. Then I'll focus on government intervention in Kenya. And even though our constitution does not precisely mention circular economy or solid waste, but we can drive some of the directives from the constitution that state that Kenyans should have a right to a healthy and clean environment. And from that, you can broadly explain that these are some of the issues of managing our waste that the constitution is trying to prescribe. So there are over 20 legal documents in Kenya from different ministries that relate to issues of effective management of solid waste and the issues of circular economy. But for our case, we reviewed only 17 legal documents. And then the major milestone in Kenya in terms of circular economy, we can see is the banning of the single-use plastic bags. That was in 2017. So at least we are making that stride as a country. And then, of course, in 2015, there was the ban of metal trade so that we can reduce theft of existing metal resources within the country, but also utilize some of the metals that are already in the market. I'll go directly to the frames. A frame is an analytical tool or a communication tool that can help you to understand more about a policy, because policies themselves are well detailed. They are complex documents. It's not very easy for you to understand, but when you do a framing analysis, you are able to pick some of the recurring themes or what are what the policy is trying to communicate. And the first one is we had two policies in Kenya that said that recommended the establishment of institutions like the National Environment Management Waste, that is the principal body overseeing environmental conservation and issues of preventing harmful disposal of waste in Kenya. We also have the Energy Act of 2019 that state that recommended the establishment of the Energy Regulatory Authority to oversee issues of regulating renewable energy, petroleum, so that the country can gain that momentum as we transition to use of renewable energy from solar, geothermal, and wind. Then also we have issues of licensing and fines. We find that most of our policy, they try to communicate that any individual industry that is disposing waste or abstracting water, they must get that approval from relevant government institutions. And failure to do that, they are liable to fines. So they can be subjected to a legal process and the court to determine some of the penalties, including a jail term, issues of giving out money so that the problem and cost to the environment can be reverted. This can be tied to the polluter pays as well captured in our constitution, and a policy like the National Waste Management Policy that prescribes that any individual who disposes hazardous waste to the Kenyan territory can either meet the cost of cleaning that waste or pay a third party affected by that waste, or even meet the cost of cleaning that and go on to pay either the affected communities or even the government. And we also seen the issues of cleaner production from our Occupation and Safety Health Act of 2017 and the Waste Management Regulations, and the recent extended producer responsibility that state that any institution, any individual must ensure that they harness natural resources in an effective way so that we can either reduce the destruction we are causing to our environment. Then we'll all look at the issues of the 3 Rs, or the policies, the 17 of them. They were well emphasizing that some of the resources, like the plastic bottles, if these community-based organizations or even individuals themselves can come up with innovative ways of trying to reuse these materials so that we reduce the pollutants in our environment. Then, of course, the policy on Public Health Act of 2017 well emphasized on provision of sanitary facilities. We are talking of sewer systems, water supply facilities like to clean up some of the wastewater that comes from either the municipal or the households. So these are some of the issues that are well captured in the policies. Then we have our Energy Act of 2019 that recommends that if the country can now move on to tap some of the renewable energy coming from either geothermal, which they have already begun doing so, and solar and wind, so that we can try to reduce some of the greenhouse gases that lead to effect of the climate crisis we are facing. Then we have one policy on national sustainable waste management that recommends economic incentives to individuals or companies that are already practicing some of these circular economy and effective waste management practices. I'll go on quickly to research and awareness. Some of the policies, like I have mentioned, the National Sustainable Waste Management Policy of 2022, they recognize that we first need to disseminate information to the public, make them understand what is circular economy and how their behavior is impacting negatively impacting the environment. So they are recommending either we mainstream issues of circular economy and effective waste management into a curriculum, formal curriculum. We can also do dissemination events through mass media, print media, and of course the social media, which is very active in the country. But also institutions like universities can play a key role in disseminating some of the research data they have already done on issues of circular economy. Then, of course, all the 17 policies, they recommend that there should be a collective efforts between the government, either the national, the county, but also international stakeholders to ensure that they can either share information or resources to support the issues of circular economy in Kenya. I'll quickly look at the gaps that exist in our Kenyan policies and a legal framework that pertains to circular economy. One is the top-down approach, meaning that there are only government institutions that are involved in designing and formulating these policies. So you find that the marginalized and the vulnerable groups in our community, they are not engaged in this process. And once this policy is implemented, it actually does not take full effect because the community cannot relate with what the policy is trying to communicate. This ties with the non-implementation because there's a lack of that community ownership of the policy. Then, of course, the political class sometimes are not well committed when it comes to, for example, there was an issue in Kenya where we wanted to locate some of these open field disposal site, but the political class are there to just deny that from happening because they are protecting the electorates, because people in that area depend on these facilities to gather materials for recycling and doing other things. Then, of course, the issue of generalization. We have very good policies, but they lack specific information on who is going to do what. So if, like for the university, they don't understand how they come in and try to support the implementation of the policy, and the community, of course, because they were not involved in formulating and designing. Then lastly, some of the recommendation we brought forth is the the adoption of a bottom-up approach in designing the policy so that we reach out to the communities and other vulnerable and marginalized groups in the society so they can be engaged from the beginning or even revising the existing policy. And then, of course, the issue of increasing awareness, either we can do dissemination. We can do the dissemination event through workshop and social media. And then, of course, the vertical integration, because of different hierarchical powers in our society, we have to bring these actors together. And so that's our paper, and we can say that the circular economy is
Excuse me, A41, your time is up. You can conclude your presentation.
Actually, I've come to an end. I can say thank you, and this was the last slide, and yeah, it is done.
Continue, yes.
Please finish
Yeah, so,
the recommendation and conclusion. I think you can ask the chair to do that, Jeremy.
Okay. Yeah, Chair, I think I'm done. Yeah, can you hear me?
Thank you very much, Professor Manene. Next one of the presentation of iswmaw from Tunisia. The presentation number A127, dealing with pyrolysis kinetics of pin wood and influence of process conditions on biochar properties. Asia, are you here? Are you connected? Asia Maawi? He is connected, she is connected, but yes. Okay, you are connected. So you can share your presentation, please.
I am Dr. Maawi Asia from Research and Technology Center of Energy of Borj Sedriya, Tunisia, and I present my work entitled Pyrolysis Kinetic of Pine Wood and Influence of Process Conditions on Biochar Properties. So, as we know, lignocellulosic wood biomass is the main source of energy in the world. In Tunisia, among lignocellulosic biomass, Aleppo pine cone is produced from the most widespread coniferous species in Mediterranean region, and it presents more than 53% of the Tunisian forests. Although these great quantities and the promising potential as biomass, local pine cone hasn't received an appropriate attention as feedstock for thermochemical process. So the objective of this work is the energetic valorization of pine cone via pyrolysis, which presents a promising alternative to reduce environmental pollution. Our work methodology concerns 4 steps. The first step is the biomass selection, and we select Aleppo pine cone as woody biomass. The second step is the pretreatment and the characterization of the selected biomass using several methods. The third step is the pyrolysis experiments, and we use a fixed bed reactor for slow pyrolysis at 500 degrees Celsius as the final temperature, 10 degrees Celsius per minute as a heating rate, and 1 hour and 2 hours as a residence time. And the last step is the deep characterization of the produced pyrolytic biochars. Starting by the biomass characterization, and from table 1, it could be seen that Aleppo pine cone sample is rich in matter, fixed carbon, and elemental carbon. Also, it could be seen that Aleppo pine cone have a high heating value. So the high organic content of the Aleppo pine cone biomass indicate their potential for energy recovery. It could be seen also the richness of this biomass with inorganic elements, in particular calcium and silicium, which affect the pyrolysis reactions and the final biochar qualities. For the thermogravimetric behavior of Aleppo pine cone biomass, it could be observed 3 main stages The first one for the moisture release, the second one for the devolatilization also indicate the cellulose, hemicellulose, and the part of lignin degradation, and the last stage for the lignin degradation and the char formation. FTR spectrum shows the presence of aliphatic, aromatic, and oxygenated compounds in the studied sample, and the XRD results confirm the richness of alipopine cone with the minerals in forms of silica and calcite. For the kinetic study, figure 3 illustrates an increase and a decrease in activation energy, indicating that the rise of activated energy depicts the existence of endothermic reactions. However, its decline shows the presence of exothermic reactions. So it could be concluded the high relationship between the activation energy and the conversion alpha, which indicate multi-stage pyrolysis reactions mechanisms, which illustrates also the complexity of the pyrolysis process. Moving now to the results of pyrolysis experiments, and we start by the products distribution. So it could be seen that that the short residence time lead to produce more biochar with a maximum yield of up 32%. And from table 3, it could be concluded that the alipopine cone biochars have a high fixed carbon and very high carbon content, indicating the good stability of their structure. Also, alipopine cone biochars characterized by a high heating value comparable to fossil fuels. Also, it could be concluded from this table that the alipopine cone biochars produced during 2 hours as residence time have the high surface area. This increase in the surface area and micropore volume is related to the further decomposition of lignin and rapid release of volatile matter, which create more developed structure. The FTR results show a decrease in all biochar functional groups and in comparison to the biomass feedstocks due to the degradation of lignocellulosic components, in particular cellulose, hemicellulose, and lignin through several mechanisms. And the XRD results reveal the presence of amorphous structure. For the same images, it could be seen the presence of cavities of irregular shape and size, and the porous structure and cracks of the resulting biochars can be clearly seen for biochar produced during 2 hours, 2 hours as a residence time. And for environmental purposes, these results are relevant for the direct application of the biochar as sorbent for soil remediation and or its upgrading for active carbon production. As a conclusion for this work, so this study aimed to find a solution to alipopine cone through the application of slow pyrolysis process and the comparison of parameters on biochar physicochemical properties. Also, the results show that the pyrolysis condition, in particular residence time, affect the biochar yields and quality. Also, the highest biochar yield was 32% compared to biochar produced during 2 hours as a residence time, and the high elemental carbon and surface area were obtained for biochar produced at 2 hours as a residence time. And this work showed the potential of thermally treated alipopine cone waste as eco-friendly and cheap for biochar production with high quality as well as respecting the environment. For the future work, more experiments of pyrolysis to understand the effect of operating conditions, in particular heating rate and temperature, on biochar quality. Also, the use of these biochar wastes as an efficient absorbent for removal of dye, for pesticides and inorganic pollutants. And finally, use these biochar derived from Aleppo pine cone as fertilizer and amendment for degraded Tunisian soil. And thank you for your attention.
Thank you very much, Dr. iswmaw, for this nice presentation and for these good results and findings. Now we can move to the, please, Asia, do not stay connected for the questions at the end of this session. Now we can move to the next presentation from our colleague from Ghana, Dr. Emma Nasfosh. Dr. Anna, are you connected?
It's the number of presentation now.
You send your presentation now?
Yes, a minute, please.
Okay.
And British, Aida, can you hear me?
How are you, Professor Ghosh?
Yeah, I'm fine. So where is your co-chair, David?
He's not connected.
Oh, so could you contact me? Could you contact me?
He is connected. He is here.
Oh,
you can see
Professor.
him. He's here, connected.
Oh, Professor David, how are you?
Yes.
I'm asking
fine,
many times.
Yeah, just now I sent him the message after hearing from our manager. So, David, you are the co-chair here and you are taking care of that, no? You know that the rating of the presenters, chair and co-chair will be doing. So are you doing this?
Yes. We are. I'm following all these presentation with the table.
Excellent.
And.
Excellent. David, do you have the format?
Yeah.
David is from Nigeria and Ida is from Tunisia. Okay, go ahead, please. Thank you.
Thank you, Professor.
Thank you very much, Professor Ghosh.
Yeah, carry on.
Okay. So I am Emma Kofua-Nsafwa, a PhD student at KNUST, Kumasi, Ghana. And I'm presenting on a review on the use of constructed wetlands as a sustainable way of managing hospital effluents. This is my presentation outline. Over the past decade, pharmaceuticals have been declared as emerging contaminants of environmental concern. And it's been established that hospital effluents add to these pharmaceuticals in the environment. For that matter, there is the need to treat hospital effluents. There are conventional and non-conventional means of treating them. However, the conventional means have challenges of being highly mechanized and therefore labor intensive and therefore being highly expensive. So in our part of the world, that's the developing countries, a switch to a more cost-effective one would be a favorable option. Constructed wetlands lend themselves as this possible option because they are eco-friendly and they are cost-effective. In fact, constructed wetlands have been used for the removal of pharmaceuticals in various environmental matrices. In this presentation, we'll consider types of constructed wetlands, their construction, design, and operation in relation to removal of pharmaceuticals. A constructed wetland is an area of land that is mostly covered by water most of the time. And naturally, they have in it their own inherent processes, like the ones specified in Figure 1. Example, sedimentation, absorption, and then biodegradation, and even aerobic degradation. So in constructed wetlands, it's as an artificial type of wetland that is done to tap these processes and utilize them. Figure 2 shows the components of constructed wetland, mainly the basin, and then there's a liner, and then the substrate. In this figure, it is soil, sand, and gravel, but sometimes it can change depending on the objective of the researcher, and then water and the vegetation. Figure 3 shows the types of constructed wetland. Mainly considering the flow, there are 2 types: free surface water flow and subsurface water flow. For the free surface, the water is in close association or contact with the atmosphere. And actually, there are 4 types depending on the kind of vegetation that we use, as specified the emergent, submerged plants, free floating, and the other one. Then the other type is the subsurface flow, which has 2 main types depending on how the water flows. And that one is vertical flow and horizontal flow. However, these 2 can be combined to form a hybrid flow. For vertical flow, you can have the tidal, the outflow, and then the downflow. So figure 4 shows the actual types of the constructed wetland. The first figure showing the free water surface flow. The second figure showing the horizontal flow. The water is channeled there and it flows horizontally in the basin. Then for the vertical flow, the tubes are up and the water drips down into the wetland. For the design of the wetland, there are some parameters that need to be considered. And these are the parameters cited here. One is site condition, where you look at the environmental factors like underground water seepage, climatic factors like temperature and rainfall, then soil factors like the topography of the land, the type of soil. Then you have to consider its proximity to settlement, because there are certain attributes or characteristics that may affect settlement around. Then, and the next thing you consider is the type of constructed wetland, as already discussed. Then the water quality. That one, it has to do with the pollutants of concern. And in this context, we are considering pharmaceuticals. However, in the wastewater, there may be pharmaceuticals together with other pollutants. Then the next thing is the hydraulic parameters, where you have to consider the flow rates, the area, and the depth. In fact, for these parameters, they can be obtained through equations. Sometimes you can assume, for instance, for the area, there are ranges of area for each design. Like there can be levels like the pilot level, the small lab level. So it depends on what you want to do, and then the depth. However, I must say that the design of constructed wetland is an iterative process that involves empirical equations that are peculiar to the type or the design of constructed wetland. Now, these equations are kinetic, zero order, or first order plug flow equations. Again, other parameters that should be considered are the substrate. Now, the substrate, there are a number of them. Some consider just water as a rooting medium. The substrate here I'm saying is the rooting medium. So some consider just water. Others to add gravels to the water. Some add sand. So it depends on the objective of the researcher. Then the vegetation, there are various species. Some are emergent, some are floaters, some are submergent. And then apart from that, you can consider the population density. That is whether a sparse population or a dense population. There has been studies that people considered 25 plants per meter cube. Then when you consider cells, you can have a single cell constructed wetland or multiple cell. For the multiple cell, you can have series or parallel, and then the series one is dependent, the effect of one is dependent on the other, but for parallel it's not. The other things that you consider are the supporting facilities, and these are baffle devices and inflow and outflow devices. For the operation, the parameters of concern are hydraulic loading rate, organic loading rate, hydraulic retention time, seasonal effect, and physicochemical parameters. Now, these parameters have effect on the removal efficiency of constructed wetland when you consider pharmaceuticals. And there can be a model concerning these to get predictions for the removal efficiency. For instance, for seasonal effects, it has been established that the seasonal effect like aeration, wind, rainfall have effect on the removal efficiency of pharmaceuticals. Again, the physicochemical parameters has mainly to do with the parameters for the water involved. In conclusion, I will say that constructed wetlands have been employed for removal of pharmaceuticals of various classes, but the removal is dependent on parameters like the design, the operation, physicochemical parameters. And from the review, it was established that further insights or further inquiries are needed to get insights about the removal efficiency of pharmaceuticals. These are my references, and thank you for your attention.
Thank you very much. So we can move now to the next presentation, which will be given by our colleague from Nigeria.
So good afternoon, dear court. First and foremost, I would like to acknowledge Professor Sadan Kumar and the organizer for inviting me to be part of this international.
Sir, could you please share it on full screen in the presentation?
It's not full screen? Okay. Yes, please. How about now?
Yes, sir. Thank you.
Perfect. So our research topic, myself, my name is Yamana. I'm employer at Adama Science and Technology University at Water Supply and Environmental Engineering Program here in Ethiopia. And our topic is, our research area is on wastewater treatment using the hybrid stage solar powered electrocoagulation and electro-oxidation process, which is the electrochemical advanced oxidation process. So please allow me to present this research on behalf of my co-authors. Perfect. For today, I will have an introduction, then finally I will finalize my presentation by saying something about the future outlooks. So as an introduction, as we know, one of the major challenges facing mankind today is to provide clean water to the vast majority of the population around the world. And this challenge for looking clean water is very critical when we see it in developing countries. It is because different rivers, water streams, in general, the water bodies are constantly polluted due to indiscriminate discharge of industrial influences. So among these polluting industry, textile industry is one, which is the largest consumer of dyestuff, chemical, and water. Because of this, it generates large volume of wastewater. If we see from the textile industry dyeing processing units, almost 30% of the dye will not be attached to the cotton cellulose. That means it will be released as a discharge. So from this, we can see how the textile industry is a significant environmental concern. And also it is characterized by high value of pollution signs like strong color, heavy metals. It has also low biodegradability and very toxic to microorganisms. So to remove those pollutants generated from textile industry, of course, there are different technologies that have been implemented, like for example, advanced oxidation process, biological and nanophysical adaptations. If we see one by one, for example, physical-chemical treatment process is an efficient technology to remove pollutants from textile industry. However, since to remove those pollutants, this physical-chemical treatment process uses gas. So at the end of the treatment process, it will produce large volume of sludge. Because of this, the use of physical chemical treatment process to treat textile industry wastewater is a limited use. When we come to the biological process, again, since textile industry, they use so those chemicals are very toxic to the microorganisms, and they are also recalled to implement process to treat textile industry. Attention has been given to this electrochemical treatment method. This is because this electrochemical method uses less chemical. It uses also less space requirement, and it is easy in operation. To and lows electrochemical treatment method that is also considered as a clean technology. Really, what was the research gaps that we have identified while we are conducting this research? In most studies, scholars, they are implementing or following the one factor at a time approach, which means varying one factor at a time while the other factor are keeping constant. So if we follow this experimental approach, we may result in the inaccuracy of optimal operating condition because we are disregarding the interaction effect between the operating parameter on the response. The other research gap is even studies that has been implemented using this hybrid electrocoagulation and electrooxidation process, but most of the literatures show that they are using the dye concentration, which is below the actual dye concentration discharged from textile industry, which is less than 100 milligram per liter. But in this research, we have considered the exact amount of dye concentration, which is expected to be get from textile industry wastewater. In addition to this, the big concern in energy crisis and climate change encourages researchers or sectors to use the renewable energy. Purpose we have used the solar energy as a renewable energy for the treatment. So here the first is what are the working conditions for the how effective are those optimum operating conditions for removing textile wastewater? How well is the treatment technology performing in terms of dye degradation or of the complex industries? Is other available technologies? So the objective of this research was to investigate the removal of pollutant from textile industry wastewater by using dual-stage solar-powered electrocoagulation and electrooxidation process. Fundamentally, the former steps as well as the existing commercial technology. So for this research project, we had two different experimental setup. One is for the electrocoagulants. So for this electrocoagulant with an effective area of 65 centimeters square, effective volume 600 milliliter. Again, for the electrooxidation, more or less, we have used similar experimental setup, but this electrooxidation process, we have used iridium oxide coated on titanium, which is perforated as anode and aluminum electrode for cathode. Why we use perforated here is if we use like a simple plate electrodes, so we may face passivation of electrodes. Reduce the passivation electrode, we have used this mesh. And again, for this treatment to consider the renewable energy as a source of energy, we have used a solar panel and we installed it at Addis Ababa University with an inclination of 20 degrees to the north direction. At the end, we have also estimated the total operating cost and we have compared it with other technologies to see its feasibility or implementation. The first procedure, the first result that we have achieved was first we have optimized the treatment system and we have observed that less color removal and CO2 removal was achieved using electrocoagulation as a separate technology. However, a maximum removal efficiency was achieved when we are implementing the dual stage electrocoagulation and electrooxidation process as a combined technology. Again, we have evaluated the mineralization study through the TO reduction. This is because we compare the effectiveness of electrocoagulation and dual stage electrocoagulation and the electrooxidation process as a combined technology in mineralizing the dye from the textile industry wastewater. So for this purpose, we have analyzed the TC analysis. So under the optimal operating condition, we have achieved only 47% of TOC reduction using electrocoagulation as a separate technology. However, as a combined technology with electrooxidation process, we have achieved a maximum of 97%. Actually, at the end, at the end of my presentation, we will see it. We achieved 100%, but maybe this 97% could be due to the instrumental reading. And also, we have evaluated the degradation analysis. We have used a combined instrumental analysis, which is FTIR and the NMR spectrum. Because why we use these two combined instrumental analysis, because we need to be very sure while we are analyzing this dye degradation extent. So as you can see from this slide, so in the raw wastewater, we have observed different functional groups. However, in the treated water, after we treated it with the combined electrocoagulation and electrooxidation process, we have observed there are absence of most of the functional groups. That means there is a breakdown of NH-amine function in aromatic rings. The same result was observed using this NMR spectrometer, as you can see from this graph. Since we didn't see any signal, that means all the functional groups are degraded. So from this, we can conclude that through the TOC reduction, the AR and the NMR analysis confirm that all pollutants from the textile industry are entirely degraded into carbon dioxide and water. The other finding is to evaluate the optimal operating condition for real wastewater, for real textile industry wastewater. And as you can see, using a synthetic wastewater and real wastewater, shows that there is insignificant difference in removal efficiency when we use the different wastewater, even for the real wastewater as well. So from this, we can see or conclude that this technology shows a promising result, and it can be also work for textile wastewater treatment as well. The other is evaluating cost or estimating the cost of the treatment system using a conventional power source, that means using electricity. And at the end, we have estimated around 1.4 USD dollar per meter cube for the treatment, which is still less than the cost of electrocoagulation and ozone, as well as the cost for using electrocoagulation and Fenton process. And then the next finding was evaluating this optimal operating condition while we are using this solar energy and its operating cost. So to evaluate the optimal operating condition using solar energy, what we did first we have calculated the total energy which is required by the treatment system, and we have calculated also the total energy that can be harvested from the panel with the panel efficiency of 85%. And as you can see from here, we have compared how much energy can be used by the treatment system relative to the total energy collected from the solar panel. So from the result, as you can see from this slide, it shows that almost 27% of the total energy collected from the small panel is used by the treatment system. So from this, we can conclude that the solar energy that can be harvested from solar panel is very enough to run the treatment system. And we have compared also the removal efficiency of the treatment system, which is the electrochemical oxidation system, using both source of energy, conventional and solar power. And we have achieved insignificant difference in removal efficiency, whether we use solar energy or this electricity.
Please, Professor.
Yes, please.
Time is over. You have to conclude, please.
Yeah, okay. So we have calculated also estimated the total energy. And when we see the higher operating cost for solar energy, this means that this is the investment cost. That means we will not have, we will have less operational and maintenance cost, or less or no energy bills will come every month if we use renewable energy. So as a concluding remark, the difference in removal efficiency using conventional electricity and solar energy is significant. Therefore, this technology can be implemented to treat textile wastewater using solar energy. So I will finalize my presentation by saying something about future outlook. According to the results, this technology is a promising technology that we can be used to completely remove pollutant from textile industry. However, it is important also to scale up this technology and test in pilot scale. And also we want to expand this research for further pollutant removal like fluoride, arsenic, and other geogenic pollutants, and also as a water purification technology in rural areas. Also, most effluent treatment plants in my country, Ethiopia, are biological in Ethiopia. Thank you so much. And we want to also a collaboration work with you colleagues. So if you want to contact me, here are my emails. Thank you so much.
Thank you very much, Dr. Imani Asafa, for its presentation. Now we have the last presentation of this session will be given by Dr. Farhawi Mohamed. Are you connected?
Yeah.
Farhawi, you are here. This presentation deals with the effects of waste management on real estate valuation case of landfills. Our colleague is from Morocco. You are welcome, and please could you share your presentation?
Thank you, dear Professor. Thank you very much, Doctor. Thank you for the organizers from the Sumaya Institute of Management and Sumaya University for organizing this very interesting event, talking about one of the most important topic nowadays. I am Farhawi Mohammed. I am head of water production department at the National Office of Electricity and Drinking Water in Morocco, and I am a PhD in science, and I am also preparing my PhD in law. I am working on the effect or the impact of the environment on real estate valuation and appraisal. My presentation talks about effects of waste management on real estate valuation, case of landfills and dumping. It is worldwide accepted that the real estate business is one of the most important economic sectors in the world. Its value depends on many factors and appraisal approach. Real estate appraisal is an issue of particular concern. It is the process of developing an opinion regarding the value of property based on the knowledge, experience, environment, and professional assessment of value by the real estate appraisers. The valuation is a very subjective topic. To assess the property's value, it is crucial to determine the influence of many factors. Many factors can affect the property value. First, we have the physical factors such as location, distance from center city, features, condition, facilities, connection, and pollution. And when we talk about pollution, we talk about a very huge issue, which include waste management and fees, air pollution, water contamination, and soil contamination. And the second factors or second kind of factors is economic factors. Economic factors plays a great role in real estate valuation, and we talk about supply and demand, interest rates, economic outlook, property market performance, and investment potential. And the third kind of factors that affect the real estate value and price is social factors such as demographic data, jobs, etc. Many studies have examined the effects of various factors on real estate value, such as location, transportation, conditions, home features, etc. However, the waste management and especially landfills and impact and dumping impact on real estate value is not much analyzed as factor of real estate value, despite its great role in determining the property value. The waste management can be considered as a price-setting factor in market price of real estate. In this study, we focused on the impact of waste management and especially the landfills and dumping as a factor of real estate valuation and appraisal. In order to provide real estate appraisers a tool to assess the property value, taking into account the waste management, we try to answer this question: how waste management factor affect real estate value, and which impact can have on property appraisal? And there are some sub questions. There are some sub questions that we try to answer via this research. How waste management factors decrease the property value, and we try to find the percentage of decreasing of the property prices in real estate market, and to which extent which waste management factor affect the real estate appraisal and the appraisers report. And does court take into account the waste management in determining the property value? Our objective is to enlighten the effects of water resource waste management and especially landfills or real estate price market, and provide tools to be used by appraisers and courts and administration taxes in real estate evaluation of contaminated properties and properties that are affected by landfills and dumping.
And you carry on. What's my point? My point is that besides this talk that we are talking about now, which has been set up.
You can continue, Doctor.
Because of
Professor.
Found out that this thing that you're saying that when you were in Lagos, because this thing when I was in Lagos, and a number of other places.
We have in the literature review, we have some research talking about evaporation and water contamination and soil contamination.
Okay. Okay, you can continue, please.
And the impact of air pollution, water contamination, and soil contamination caused by dumping and landfills, and how the property value decrease according to air pollution and water contamination and soil contamination, and also noise contamination. And the percentage of the rate of decreasing is depending on the environment in general and depending on the context and the geography. Our legal framework that we are based on is in Morocco. We have based this research on some laws and some regulation. Such as environment law about environment protection and the impact on the environment, and law 13.0.03 about air pollution, and law about talking about water and water contamination. And for real estate appraisers, we have two laws in Morocco about talking about the first talks about judicial experts, and the second is civil procedure code. This dumping and landfills can cause many kinds of pollution, such as air pollution, water contamination, and soil contamination, and noise pollution. We talk about silence is golden. The methodology of our researches is based on an analytical approach. We have based on first on a survey of transaction around the dumping. The second is the laws and standards. The third is scientific articles, research findings, and recent court decision. And in final, we have based our research on real estate appraisers report. For the practice or for the implication of this research on the practice, we have conducted a survey around the Sbayoun dumping located in the middle of Morocco. In the middle of Morocco, the dumping is, and we have conducted a survey about in more than 60 transactions around this dumping, in order to determine how the dumping impacts and affects the real estate or the property prices around the dumping, taking into account the water pollution, soil pollution, air pollution, and noise pollution. And the finding of this survey and this research, we find that the real estate prices decrease up to 15% for the properties next to the public dumping. And we have conducted this study in order to determine how the dumping or how the landfill impacts the properties in its surrounding. And we have based our research in many recent court decisions. In Morocco, we have many court decisions about air pollution and water contamination. And in this court decision, the judge take into account the air pollution effects on real estate value. And for water contamination, we have many court decisions, and water contamination due to the landfills and dumping affects the real estate or the property prices in the real estate market. In conclusion, waste management is not much analyzed as factor of real estate depreciation. The study aims to enlighten the effects of waste management on properties price market and raise awareness of real estate appraiser about impact of waste management, especially landfills and dumping, urban dumping on properties values depreciation. The study would be helpful and provide baseline knowledge for real estate appraiser, for judge, for administration taxes, and prove the role of the waste management and the environment protection and preservation on real estate value. And so takes and my presentation. Thank you very much for your attention. And there are a lot of references that we based on in order to conduct this research and this presentation. Thank you very much.
Thank you, Dr. Mohamed, for this good presentation. Since we have a short time to question, please, for all attendees, do you have a question to previous presentations? So I have one question to Dr. Kudirat Ademi. I don't know if she's connected already. I have a question about the next step of her work. What do you plan to apply this technology, and in which sector? Since Dr. Ademi is not connected with, I will move to the next question to
Dr. Ademi is online. Dr. Kudirat is connected.
You are in line?
Your question, ma.
Okay.
Your question, ma.
Yes, please. Which is the next step of your work, and do you plan to apply your concept or your technology, and in which sector, please?
Yes, the next plan now is I would like to have a comparison. That's do another acquisition of data, since the black soot is not too noticeable at present in Port Harcourt City, so that we can be ascertained with the 2017-2018 findings. So with that, we can now make a comprehensive conclusion on the acceptability of the methodology that we have used, so that we can move further in order for us to get solutions to the challenges facing climate change instead of the long-term frame. Then we can abide that methodology for a short-term frame results. Thank you.
Thank you very much, Dr. Ademi. So the next question is for Dr. Jimar bin Sidhom. Jimar, are you connected?
Yes, Dr. Aida.
Okay. I wrote the question about which is the advantage of the use of PGCMS instead of pyrolysis and the analysis of bio-oil separately.
Okay, that's a good question. Actually, the advantages of PGCMS over separate pyrolysis and GCMS analysis of bio-oil include improved efficiency as the PGCMS in a single step, such as saving time and resources. It also provides real-time data, enhancing the ability to capture volatile compounds that might be lost in traditional sequential methods.
Okay, thank you, Jimar. I have a question also for doctor who is from Kenya, who present the waste management in Kenya and the circular economy status in Africa and in Kenya in particular. Are you connected?
We are here. Jeremy?
Okay, so
Yes.
my question is, what about waste to energy in Kenya? Is it well developed in your country?
Waste energy?
Waste to energy, I mean the extraction of energy, biofuels from waste. Is it a practical? Is it a practice in Kenya?
Can I get that very clearly? The waste that come from what type of materials?
Yes, in waste management, we can extract materials from waste, or we can extract energy. So we have technologies of waste to energy. Is it these technologies are developed or not in Kenya?
Let me just try that, and by saying that we specifically look at the regulations and policies that are developed to facilitate the waste management or sustainable waste management in Kenya in following the principles of circular economy. So we reviewed a number of policies and regulations, about 20 of them, and some of them actually may reflect or imply that the energies that may come from waste can be developed through creative innovations in the area of circular economy, in the area of innovation that we need to use, and all types of waste that we have in this country. And also, once we have those kind of innovation related to energy, we can share with the rest of the countries in Africa and other areas. Maybe
Thank you very much.
my colleague may also add if he has, Jeremy, if you have any other addition you can add. Thank you.
Okay, thank you for this exhaustive response. After we have a question to our colleague from Addis Ababa, who presented the importance of energy and solar energy. My question is, do you apply your technology of electrochemical technology with solar energy to industrial scale?
Thank you so much, Dr. Aida, for your nice question. Actually, as I said it in the last of my presentation, the treatment system in Ethiopia are biological systems, so we want to introduce this electrochemical technology system to the industries. So now we are preparing to install this technology in 3 different industries as a pilot scale, so as the industry stakeholders can see and evaluate its efficiency, and they can apply for their treatment system.
Okay, nice. We have a question or a remark from our colleague Farhawi Mohammed. I don't have a question for you, but you can have the Dr. Mohammed.
Yeah, thank you. Thank you, the professor. Thank you very much for. Thank you, Mr. Yemen from Ethiopia, and thank you for all the presenters for the presentation. My question is about the price of the application of hybrid solar powered electrocoagulation, taking into account the capex and opex. I don't know if they compare the price of conventional energy alimentation and the hybrid solar powered electrocoagulation. Thank you, Professor.
Thank you, Fraul. Nice question again. Actually, we have compared it and we have estimated the total cost of the operating cost of using electricity as well as using solar energy as a different source of energy. Of course, we have found using solar energy is high in operating cost, but as we know, using a renewable energy as the beginning, it could be high in cost, but we have to consider that this is an investment cost. Because if we compare if we use electricity, we will pay every month a bill for the electricity. But using solar energy, we may not have those bills coming at every month. So even though the estimated cost of the treatment system using solar energy is higher, but we have to consider that this is an initial investment cost. Thank you so much.
Thank you very much for your question. Do you have a question to Dr. Mohammed? I have a question to Dr. Mohammed. In Morocco, you are which is the technology you are using for the waste management, solid waste management?
The professor. Thank you very much for your question. For waste management in Morocco, we have usual technology, and we use dumping for waste for managing urban wastes. And for wastewater, we have many process to treat wastewater. We have lagunage, we have activate sludge, and we have also the third technology is about bacterium. Yeah. I hope that I answered. Thank you.
Okay. Thank you.
Our time is up, and we have another program already started. That program is already started, and we are late by 15 minutes. So I will finish. And one more thing, before you conclude, kindly ask all the participants present online to open their camera so that we can have a good program.
Okay. Did Dr. David is here? No. So I will conclude. This session was dedicated to waste management and circular economy in African countries. We have some experience from Kenya, from Nigeria, from Morocco, from Tunisia. We have 2 presentations from Tunisia. From Ethiopia also, and it was very interesting presentation, an exchange of experience in all our African countries. So I want to say thank you for all presenters. Thank you to all attendees in person or in on virtual platform. Thank you also to all organizers of this new session of ICON, and special thanks to Professor Ghosh, who is inviting us for this conference. So thank you to all of you, and thank you to our colleague David Lucani, who co-chairs this session. Allez, ciao. We see you in other sessions. Ciao. We have to do a group photo. Please turn off your camera. Hi, Dr. Ghosh. How are you?
Very good. How are you doing?
Thank you. Thank you.
It's good to see you. Thank you for organizing a good group that made the presentation from that side.
Thank you, Dr. Ghosh.
And that is very good. Thank you. Now, photo time.
Thank you very much.
The photo is already taken, and thank you all.